Welcome to New Frontiers, a show that's all about exploring the science, discovery, and innovation happening right here at the University of Arizona. I'm your host, Erika Hamden, and today I'm at the Kuiper Space Sciences Building, home of the Lunar and Planetary Laboratory. This is one of the world's largest programs dedicated exclusively to planetary science at a university. And some of NASA's most historic missions have been spearheaded right here. For this episode, we're going to look at some of the most recent missions to explore near-Earth asteroids. These are the rocks from space that could one day threaten our planet, but they can also hold clues to the origins of our solar system. So let's go. First, I'm on my way to the Astromaterials Analysis Lab, where we'll get to look at actual samples from a billions of years old asteroid. The samples were returned last September as part of the U of A-led OSIRIS-REx mission, the first time that NASA has brought back samples from an asteroid. Our cameras have been with that mission since its inception, and of course, had to be there for the conclusion. And the conclusion was thrilling. Check out our story on it, and then meet me afterwards in the lab where we'll do our own analysis.
Welcome, and thank you for joining us live from the Army's Dugway Proving Ground in Dugway, Utah. This is special coverage of America's first asteroid sample return mission, OSIRIS-REx, as it arrives back to Earth after more than 7 years traveling in deep space. Let's turn it over to our mission commentator, James Traley, to take us through the final moments. James, we're all yours.
Yeah, Lauren, buckle up and get ready for the ride of entry, descent, and landing. In just a few moments, we're going to hit that key milestone of punishing descent through Earth's atmosphere to us here in the Utah Test and Training Range.
EO milestone, the SRC has entered the Earth's atmosphere. UTTR tracking assets have acquired.
And here we go. This is from our infrared tracking camera on the WB-57, our high-altitude plane. Getting a great view of that SRC heating up as it comes in at about 27,650 miles an hour. You can see it glowing brightly in the sky. Very quickly in, we're going to deploy our drogue parachute. This is for stability, stabilizes our descent, and make sure that we are continuing to target that landing ellipse.
Expected EDO milestone, SRC commands drogue parachute deploy.
So we heard that command to deploy the drogue parachute. Waiting to see that visual confirmation. Still quite warm, that fireball that literally was a ball of plasma just a few moments ago when it first entered into the Earth's atmosphere. We continue to track with our high-altitude camera here.
The only thing that I needed to know was that that parachute deployed, so obviously I was keyed into that more than anything.
I've had a lot of heart-pounding moments, yeah. I often ask myself, how many can you handle in one lifetime, right? It's like, I think I might be hitting my limit here.
Status check.
Go Atlas.
Go Centaur.
Go OSIRIS-REx.
10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of OSIRIS-REx, its 7-year mission to boldly go to the asteroid Bennu and back.
For the actual launch, it was just transcendental. Like it was a true out-of-body experience. It was like I was there with OSIRIS-REx as we lifted off, into the stratosphere, into orbit, and then that final burn, which sent us off into the solar system. And I was like, fare thee well, man. We got an adventure ahead of us. It's just beginning.
If you vanish, Centaur is now orbital.
We've worked hard to get to this point. The best times are ahead of us. We are going to get to asteroid Bennu. We're going to map it. We're going to pick that site. We're going to get that sample, and we're going to bring it back to Earth.
And then the moving dot here is actually the asteroid.
Monday, December 3rd, 2018, the spacecraft ends its approach to Bennu.
We have arrived.
It's an amazing time right now. The spacecraft is working, the camera is working, everything looks go to get into the science campaign. So the winner of the OSIRIS-REx Site Selection Championship is the Nightingale site. All right. We're feeling pretty good. Everything's gone really well today. Earlier we departed our orbit around the asteroid, so we're flying over the sunlit side of the asteroid. The spacecraft has deployed its robotic TAGSAM sampling arm, so the arm is ready.
OREX has descended below the 5-meter mark. The hazard map is go for tag. Contact expected in 50 seconds.
We're going in. We're going in.
And we have touchdown!
Touchdown declared.
So Bennu has surprised us every step of the way, and sure enough, we went down into the asteroid this deep. We collected so much material, it was leaking, and particles were just spewing out into space. So one last emergency, no worries, we'll figure it out, and we quickly got that sample stowed, tucked away into that capsule, and closed up and ready for its journey home.
We want people to realize the impossible, to see what you can do creatively, constructively, when people come together.
We are here at the Utah Test and Training Range. In less than an hour, a 4.5 billion-year-old piece of the ancient solar system will be landing here in the desert. For now, let's give you a quick geography lesson on where we are today. We are sitting about 85 miles southwest of Salt Lake City in the heart of the Dugway Proving Ground, a historic Army facility. The sample will touch down in our landing ellipse about 13 miles north of where we're speaking right now. Mission teams have set up a clean room just 1 mile away from us where the sample will end its journey today. We've got a lot to discuss and a huge adventure straight ahead. This is live coverage of NASA's OSIRIS-REx sample return.
The day actually starts really early in the morning, and there's a critical decision at 2 a.m., go, no go. Are we releasing the capsule, or are we in a situation where we have to hang on to it and delay the sample return by 2 years?
Yeah, okay.
I voted go, so that's on record. PI's go, right? But I don't get the safety vote. And then there's a whole series of commands and operations that happen to the spacecraft, ultimately releasing the capsule where it hits the top of the atmosphere about 4 hours later.
Just a little bit further north from us, about 4 hours ago in Waterton, Colorado, the team met to assess the readiness to release the SRC from the main OSIRIS-REx spacecraft. And I'm very happy to report that they gave the green light, they gave the go command officially. And in just a few moments, the SRC itself will be streaking across the skies as we begin to track it.
That's when the field team activates. We arrive here at the Michael Army Airfield, and we get into our helicopters, and we fly off to just outside what we call the landing ellipse. And then we wait until we get confirmation that we can see the parachute opening up. This is where the final end game of OSIRIS-REx plays out.
So this is it. We are just 15 minutes away from the OSIRIS-REx sample return, a journey of 7 years and nearly 4 billion miles. The work of thousands culminates in this moment.
See on your screen now the mission ops team eager at the edge of their seats for that first call out of Earth atmospheric entry. Very exciting moment coming up in just a few seconds here.
EO milestone. The SRC has entered the Earth's atmosphere. UTTR tracking assets have acquired.
Start your stopwatch right now. We have that expected milestone of entering into the Earth's atmosphere. Phenomenal view of that streaking SRC coming in across the sky.
At the end of the day, we know we've done the best job we can, but the thing I worry about the most is we have to power up the sample return capsule. And there's a battery system on there, which we haven't talked to, which releases the parachutes. So if we try to power up the batteries and they're dead, we're throwing a dead capsule at the Earth.
Our next milestone, we'll be expecting that drogue parachute deployment. Quite a challenge to track this as it comes searing into Earth's atmosphere.
I can tell you what we expected to happen. The drogue chute is commanded to deploy, and then 360 seconds after the drogue, the main chute. I could not see whether or not the drogue was deployed in the imagery that I had available in real time in the ops room.
You can see our SRC streaking in. We see.
CDL milestone. We have confirmed parachute deployment.
Wow, and after an exhilarating streak across Earth's atmosphere, we have parachute deployment. You can see just a sigh of relief from the team. I can hear some applause here. There is that orange creamsicle color parachute, just a delight, a sweet delight to see in our sky here over the Utah Test and Training Range. A phenomenal view, just wonderful to see that.
And I knew the moment the chute opened, that was it. It was overwhelming relief, gratitude, pride, awe, and really trying to convince myself that I wasn't dreaming.
And touchdown of the OSIRIS-REx sample return capsule. A journey of 1 billion miles to asteroid Bennu and back has come to an end. And you can see now the SRC. At last, we have a visual of it on the surface of the Utah Test and Training Range. And there is landing of our first helicopter at the site, and the rest of the team is closely behind, ready to land at the recovery site to begin operations.
Yeah. Looks good, huh?
Yep. Look, heat shield down.
Yeah.
Heat shield down, sitting straight up.
Parachute right next to it. I was fortunate enough to be one of the first people to lay eyes on the capsule, and boy, did we stick that landing. It was just sitting right there. Oh yeah, look at that. We think we've got a lot of sample in that science canister, and we can't wait to crack into it.
Recovery operations. Helicopter 1 is cleared to depart the recovery site with the SRC.
And it is off the desert terrain, in the air, with the SRC in tow.
OREX on 3. 1, 2, 3.
OREX!
This is the final leg of the journey of the SRC. It has been loaded on the helicopter a few minutes ago, and as we speak, team members are staged and waiting just outside that clean room, ready to get that SRC back on the ground once more.
The key objective for me, and one of the driving objectives of this program, is to try to understand, did carbon-rich asteroids like Bennu deliver the compounds that may have led to the origin of life on our planet, the origin of Earth as a habitable world? I was there when it was nothing but a PowerPoint on a slide in a proposal that we were submitting to NASA with this dream that we were going to bring back samples from Bennu. So it was amazing and emotional. As incredible as it seemed all those years ago, it came to be. The Earth gravity assist was a great exercise for the team. So it was the first time everybody showed up here in Tucson because we were doing science operations here. And so it just had that vibe, like all of a sudden everybody's here, we're excited, we're just getting ready for Bennu. And this is just a dry run, a rehearsal to check out all of our instruments.
That's great.
And then that picture of the Earth showed up on the screen. And it was like a Carl Sagan moment. It was like, you know, the pale blue, the famous pale blue dot. And it's, you know, you just see it. It's like, that's us, right? And that's everybody on Earth is in that one picture. And you just realize how fragile it is, how beautiful it is, how rare it is. And really, you know, I wish everybody could have that moment because I think we would take better care of ourselves and our home world.
Capsule is turning around. Oh, that view is tremendous.
And I think we need to appreciate that, this is a gift that we've been given, to be alive, to be conscious on this beautiful world, to have all of these capabilities, to learn about our place in the cosmos, to wonder about it. They call it the overview effect, right? When you see the world from space. The scale of everything. The Earth seems really big, but it looks so tiny when you see it like that.
Hey, Tom.
Hi, Erika.
So great to meet you.
Nice to meet you.
Thank you so much for having me.
You're welcome.
I'm really excited. So tell me a little about the lab.
Yeah, so welcome to the Kuiper Astromaterials Analysis Facility. This is where we can look at the Bennu sample all the way down to the atomic level.
All right. I haven't been waiting 4.6 billion years for this sample, but I am very excited.
All right, let's go. Hey, come on in. Okay, so this is the lab where we have visible light microscopes and also an electron microscope where we can look at the sample and get a first pass sense of what it might contain.
Okay, so are we looking at actual samples from Bennu?
Yeah, so this is literally mineral grains that were collected off the surface of the asteroid.
Okay, so can we look at some
absolutely.
samples?
Definitely, let's go look at samples. They're over here. So before we actually touch the sample, we want to put on some gloves.
You gotta be extra careful with these.
Absolutely. And if you look at it, you can hold this now. And if you kind of hold it up to the light and look through, you'll see the dark Bennu dust.
Oh, wow. Dust from another world.
Exactly.
Is this gonna help us figure out the origins of life on Earth?
Yeah, it certainly should help shed light on the kinds of molecules, organic molecules that may have been delivered to the early Earth.
Seems like a really good reason to go all the way out there and take a piece of an asteroid and bring it all the way back.
Absolutely. Why don't we go to one of the other labs where we can get really close at the most fundamental level, which would be the atomic level.
All right. I love atoms. Let's go.
Let's go. Okay, so welcome to the Transmission Electron Microscope Lab. It's a large instrument. It's the highest resolution instrument in the facility, and this one is capable of seeing down to the atomic level.
So is that what we're looking at in this picture that's here?
Yeah, so what you're looking at here is actually a sample of a mineral called perovskite. And each one of these white dots are the atoms in projection, and you can kind of think of them as like strings of pearls.
So we're looking like those little dots are atoms.
That's right.
That's amazing.
It's amazing, yeah. And objects like this have been radiometrically age dated to 4.567 billion years old.
Like when the sun was forming.
Exactly, exactly. The earliest stages of the solar system.
Your whole lab setup is really astounding. I feel like the very precious asteroid samples are in really good hands with you.
Oh, thank you. Yeah, and it took years to build the facility, and we're really excited about what this next several months and next couple years hold.
Well, I appreciate your time so much. Thank you for giving me this incredible tour, letting me hold a sample, which is probably one of the highlights of my life.
That's great. You're welcome. Pleasure to have you.
Yeah, thank you so much.
Thanks.
Next up, I'll be visiting some of NASA's official planetary defense officers. These are scientists from the University of Arizona's Space Watch program who are scanning the night skies, looking for asteroids that might one day impact the Earth. These people are going to save civilization. So check out our story on them and then come meet me afterwards.
When we're observing, we drive up to the mountain in the mid-afternoon. Then we will start up and do a walk around both telescopes to make sure everything looks good. The 1.8 meter and 0.9 meter telescopes that we use are on kit peaks. And the 0.9 meter telescope is actually the original Steward Observatory telescope that started off on campus in 1922. One thing we need to do is choose our first targets and then start up all the software that we need to operate the telescopes. Then we also do a pointing to make sure that we're pointing exactly where we want to be pointing in the sky. And then we're ready to start taking images of asteroids. I'm Melissa Brucker. I work for the University of Arizona in the Lunar and Planetary Lab, and I'm the principal investigator of Spacewatch. And we use telescopes on Kit Peak to measure the positions of asteroids to make sure they don't get lost. Why don't we check out this one up here?
Okay. May I zoom in?
Sure.
Okay, so go ahead and stack the blink, right?
Yeah. It may possibly be rotating. It looks a lot brighter in the last image.
Yeah, and the stars appear uniformly.
So at Spacewatch, there are 7 of us who operate the telescopes, including me, and we can have anywhere between 24 to 38 nights per month on the telescope.
I always click this button, ping all, and dismounts. And these both should be normal. So as the lead engineer, I go up to the mountain once a month to start the run. Starting the run is an all-day activity where I go up there, turn on all the power, test all the telescope motions, rotate the domes, open the shutter, basically make sure it's going to work that night for the observer, whoever that may be. There are, I think, 88 steps total from starting up the telescope, observing all night, and shutting it down that the observer has to do every night to use and then safe the telescope at the end. Everything looks good. For me personally, it offers a way to introduce a cycle. Life is full of cycles, and this allows me to kind of get away from the daily grind, if you will, and just kind of observe. And when the sun sets, the domes can open. I do get that sense of awe looking up the night sky, and it is amazing how dark it is on Kit Peak. You can actually see the Milky Way in all its glory.
It's really great operating the telescopes and seeing the images come in. Often the asteroids that we're looking at are not bright enough to be seen in one image. So we take a series of images and then stack them together at the point where we think the asteroid should be in each image. So we end up with a dot for the asteroid and a line for each of the stars. So we have a NASA grant that funds our observations, and it is part of the Planetary Defense Coordination Office. So our goal is to reduce the uncertainty in our knowledge of where the near-Earth asteroids are as an act of planetary defense. And some of the more famous asteroids we looked at are Didymos, the target of the NASA's DART mission, the Double Asteroid Redirect Test. The goal was to nudge the asteroid by impacting it with the spacecraft. So they wanted to deflect the asteroid so that if it was one that could hit Earth, it would be moved. So we're not superheroes, but by being funded by NASA, we do fall under the auspices of the Planetary Defense Officer.
What makes this job fun to me is being able to be part of the entire cycle of operations, from designing the equipment to building it, to testing it, to using it, to submitting the data. I really believe in what I do, that there are rocks flying around in space, and one day a big one will hit us. It's inevitable. And I don't lose sleep over it, but I am glad there are people looking. And I hope that we can build a system that gets better and more efficient every year, and one day might help save civilization. It's great to be a part of that.
It's pretty exciting to observe an object that is a potential asteroid. And when you actually see it on the screen, blinking across the images, you're like, I did the job, and I'm saving the world.
Hello.
Mike, so nice to meet you.
Erika, nice to meet you. Welcome to the Space Science Class.
So thank you so much for having me. I'm like really excited to hear about how you guys are gonna save civilization. So like, what's new in your work?
So we've been doing a lot of follow-up of the targets that our joint survey with Catalina Sky Survey has discovered on Kitt Peak. The goal is to find all of the 140 meter sized asteroids and near-Earth asteroids and larger.
So is this some testing that you're doing now?
Yeah, so right now we're developing a new camera system for the 90-inch telescope, one of the telescopes we use.
Okay.
And we're subjecting our camera to some thermal tests where you can see a bunch of squiggly lines going across the TV here.
Yeah.
We're keeping track of several parameters as we optimize the system.
So is this new work and like the new camera gonna help you to better understand the orbits of these objects?
It'll allow us to increase our sky coverage. We can take with a single picture is about 4 times as big.
Okay, so I have one last question for you. For everyone watching at home, should they be worried that civilization will be cut short by an errant asteroid?
Definitely no, you should not be worried.
You should not be worried because we're on it.
Well, I will sleep way easier tonight. Thanks so much for taking the time to talk to me. This was really fun and informative.
Thank you for coming over.
Thanks for stopping by.
Thank you so much. Thanks so much for exploring the solar system with me on this all-new episode of New Frontiers. I'm Erika Hamden, and I'll see you next time. Make sure to stay tuned for future episodes where we'll explore more of the incredible innovation happening here at the University of Arizona. And if you want to know what's happening with me, follow my Instagram at Erika Hamden.
Hello, everyone. Thank you so much for joining us. I'm here. I'm Bryan Nelson. I'm the producer of New Frontiers, and I'm here with Erika Hamden, of course, our host, which you all just got to see. I want to let everybody know that we have a chat, a Q&A chat over here on the side. If you have any questions, you can certainly enter in those questions. We'll try to get to as many as we can. Before we get started, though, on the questions, we've got a few that have been submitted already. I just want to hand it over to Erika. Erika, why don't you tell us a little bit more about you and your background for the people that haven't seen all the episodes of New Frontiers yet?
So thanks for joining us. I'm a professor of astrophysics at the University of Arizona. I've been a faculty member since 2018. My specialty is ultraviolet astronomy. So I look at the wavelengths of light that give you a sunburn. Most of my telescopes are in space for that reason, because they're blocked by the atmosphere. But I'm interested in understanding how galaxies form and how stars form. I don't care about the object once it's there. I want to know how it gets created. And I also really care about sharing science, space science, all sorts of science with the public, because I think that what we do is really cool and it's important to, talk to people about what we discover. So I have a little Instagram account where I talk about weird things in space, and this show is something that also appeals to me in that way, because I can show people what's happening at the university, where we have some really incredible scientists doing all sorts of different topics, not just on space, but on all sorts of things. And so it's really fun to kind of showcase some of those exciting projects.
Great. Yeah. And for those of you who just saw your first episode of New Frontiers, or, aren't, maybe you didn't even know that we were doing this program at all. It is our new show that is focused on the science and innovation, particularly that's happening at the University of Arizona. And all of our segments are also co-produced for Arizona Illustrated, our regional TV flagship program here, which I'm sure many of you are very familiar with. But we get to repackage those and just talk about the science questions and the science stories that so many people are laser focused on, because we are, of course, here at the University of Arizona, one of the top research organizations in the entire country. So with that, let's just jump into some of the questions. We've got a couple of questions that people sent in beforehand. Again, I want to just remind everybody that you can send in your Q&A questions to the Q&A box there in the Zoom panel. So our first question asks about what are the current proposed projects to intercept dangerous asteroids and other objects that are orbiting the Earth. So perhaps our story on Spacewatch answered a few of those questions. The most recent one, of course, that's featured in that story is the DART mission. And that one was effective at slamming into a moon of the asteroid Didymos. And they're still measuring exactly how much it did deflect that object, but it was successful. Erika, do you want to talk a little bit more about some other missions, or a little bit more about the DART mission?
So the DART mission was actually really innovative because it was a test of whether we could change the orbit of something, and so it worked like surprisingly well. So I think I don't know off the top of my head if there's other missions that are trying to. I think there is another one to.
I do know that there is there is the Hera mission as well, which is a follow-up to the DART mission that's going to the same asteroid, and it's going to get more precise measurements. And that one's being launched by the European Space Agency. So I know that one's out there.
Yeah. I think with all these missions, the thing that's really important is if you have to detect your asteroid like pretty far, reasonably far in advance, so that you have time to like send something to it. And the earlier you can change the orbit, the bigger of an impact it will have like later on.
Exactly. And that's one of the reasons why the work from the Spacewatch crew here at the University of Arizona is so important. They are working to try to find every single potential threatening object and find it far enough in advance so that we can have hopefully decades and decades to plan ahead.
Yeah. It's a tricky business.
Absolutely. One other thing that we should mention too is the follow-up to the OSIRIS-REx mission. The OSIRIS spacecraft is going to another asteroid called Apophis very soon in 2029. And that asteroid's going to come within the orbit of the Earth and the Moon. So it's going to get very, very close. And the spacecraft is going to be able to get really close to it as well, and measure exactly how the Earth's orbit sort of shakes it, so that we can better understand that asteroid as well. Okay, let's get on to another question. This question might be kind of fun for you, Erika. Is any of your research focusing on the phenomenon of extraterrestrials and their presence on Earth at this time?
So none of my research is focused on that. I get asked a lot about extraterrestrials as a scientist who works on space stuff. And let's see, I believe very strongly that we are not the only life in the universe, that I think there's probably lots of life everywhere. We just have to find it. And probably most of it is like just little single-celled organisms. But I also think that it's likely, just given the size of the universe, the number of stars in our galaxy and the number of planets, that there's probably intelligent life. What I don't think is that it has come here to this Earth, because the distances are so huge, and I think travel between stars is a really complex problem. I also feel like if there was a civilization that figured out how to solve that problem, they would not be hiding. They would just like show up in a giant spaceship and we would all know. So partly like I don't think that it's like there's like any secrets about it, but also I just think that the distances are so huge that it would make it really hard to travel. But I definitely think there's life here, and I don't think that we're that special in any way.
And I'll just add too that the OSIRIS-REx mission, of course, that's one of the things they're hoping to. I mean, that's what the O in OSIRIS means. It's origins, and they're one of the hypotheses that they're trying to test is whether or not like the building blocks for life might have come from elsewhere, from elsewhere in the solar system. And that's something that they're still trying to figure out, of course, with sample analysis. I don't know if you want to say anything else about that, Erika.
So it's definitely not my expertise, but the sample analysis has been really exciting to see. I mean, they're seeing these, it was a little hard to catch in the video because it's like on a screen in the back, but they're seeing these like clumps of material that indicate that at least when it formed, it was a very like aqueous, like very water heavy kind of like muck. And I think they're finding some really interesting like amino acids and some of these more complex molecules that are amino acids are the building blocks of proteins, and just components that haven't really been observed we've looked at meteorites on the Earth when they like pass through the Earth's atmosphere and land, but those are always contaminated because they're sitting on the ground, and they've also been through the atmosphere where they get like really heated up and they can like change their kind of phase and structure. And so these like really pristine samples are incredibly valuable because they haven't been contaminated. They took so much care in how the sample return capsule was like structured, and so a lot of the stuff that they're seeing is like basically brand new. And one of the things that I really liked that we talked about in the lab was, you know, they have this sample, which is, I think it's less than 100 grams or 200 grams. It's not a lot, but they're saving more than half of it for future investigations so that, you know, in 10 years or 20 years when we have better technology, and they'll be like, I can't believe what those people were doing in the 2020s to these samples. They'll be able to like do all new experiments on them. And I think that is really cool how we're not going to be limited just by like what we can discover today.
And that feeds perfectly into our next question, which was about the specific constituents of those samples and what they actually contain. Of course, I want to point out that we are not researchers on this mission. So
unfortunately.
And they're still processing that. In fact, the images that we showed in the episode today were embargoed at the time, and we got special permission from NASA to show you those. So they are those are going to be coming out in the years to come, in the months and years to come, exactly what's in that sample. But we were told that there are, you know, they have found organics, there's water trapped in clays, that sort of thing. But the exact details of that, you've got to follow the mission. I don't know, Erika, if you've heard anything on the inside track besides that.
That's all that I've heard, but we'll have to wait for the papers to come out in Nature and
Absolutely. And hopefully we'll make another story about that down the line. So stay tuned. So another question here from Sydney. When you're doing stories like these, how do you balance giving scientific information while also making it approachable for an audience that may not be deeply familiar with it? So I guess that's a question for me.
Yeah.
I am the producer behind both, so I put together both the stories that were also featured in this episode, which are the OSIRIS-REx and the Space Watch stories. You know, that's what my job is about, trying to balance those things out. I do have a science background as a science journalist, so I've been writing about science topics for about 15 years or so. And so, you know, I take it seriously to try to get the science right, and I'm deeply curious about it myself. But at the same time, making it accessible to people is what I do as a storyteller. And a lot goes into that. I think a big part of it is honestly just finding really great charismatic characters. And here at the University of Arizona, we've got that. People doing really inspiring big work. So they make it easy for me, I guess. On Arizona Illustrated, we've actually done a story on Erika as well. If you guys want to look it up, it's called Fireball, and she's one of those charismatic characters as well. Maybe she can give you a little behind the scenes of what it's like to be a character in one of these stories as well, and how that comes together.
I mean, it was fun to be a character in one of those stories. I was like in the middle of the pandemic. That was like an interesting experience. I think like one of the important things is to really talk about why you want to do something, or like why are you doing the scientific work. Like a lot of what you see is like the end result, like the sample, the capsule like landing and everyone's like very excited. What you don't see is like all the thousands of people toiling for years and like going to the lab every day. So for me, I feel like the being able to convey both like the end result, but also some of the like process of how it actually happens, I think is really interesting. And that kind of drive, like, why do people show up every day to like look at these tiny specks of dust now, and what makes people want to spend their nights looking for asteroids? I feel like that if you can convey like why somebody does it, that helps other people to understand why it matters, and you get a better sense of like the kind of passion that people can bring to it, and that I think helps with the understanding. And of course, I also believe very strongly that you can explain the most complicated science to a person with no science background. I think that there's like this feeling like, oh, this stuff must be so complicated that you have to be a genius to understand it. But I don't think that that's true. I think you can explain like sophisticated, accurate science to a layperson that's just interested in learning about it. You just have to like think about how you're approaching it and the language that you use. And so it's great to work with Bryan, because I feel like he really understands that. And it may, you get like a little bit of the human story of like why these people want to do it. And then you can also learn about what we're actually discovering.
Absolutely. And of course, if you guys haven't checked out Erika's Instagram page, she does a lot of this herself, answering really, really hard scientific questions in a very accessible way. So I definitely encourage you to check out her Instagram.
I have a lot of Eclipse content right now.
Oh, yes, the clip's coming up, of course. Yes.
Oh, and there's a question in the chat that's about if we can talk about the upcoming solar eclipse.
Yeah. So somebody liked Erika's glow-in-the-dark glasses in the video.
They don't actually glow in the dark. They're just like turquoise colored. But thank you.
And also they also asked, do any of Bennu's rocks glow in the dark?
I don't know. I don't think that they've checked. That would be very interesting if they were like phosphorescent. I feel like that should probably be something that they're going to test out in the like normal sequencing. But that would be pretty cool.
Yeah, absolutely.
Bennu was very dark. It was not glowing when the spacecraft arrived.
Yeah, I know the samples that we got to check out were just black, as it's just very dark. So I'm going to say no, they don't glow in the dark, but who knows? Maybe. Another question from Harmony. What originally sparked your interest in astronomy and the universe? Was there a question that was behind this curiosity? And if so, do you feel that you've gotten closer to answering it? Or is that not even possible? Erika, I'm going to leave that to you.
Okay, so I actually talk about this, I think, in the Arizona Illustrated piece about Fireball and my work on it. Fireball is a telescope. But so I got interested in astronomy when I was like 6 or 7 years old. My mom said something to me about the Big Bang, and I was like second grader, and I was like, I don't know what that is. And it was the 80s, so she told me to go look it up in the encyclopedia. So I went upstairs to our encyclopedia, and I looked up about the Big Bang, and I was like, whoa, this is cool. And I like looked up all the other stuff about space and the universe, and that like vastness and kind of, I don't know exactly what it was about it, but it just, I was like interested instantly. And like, then I would bug my parents to take me to the library to take out books about space. I read like every book about space in the library. And then I learned how to program the VCR at our house so that I could record actually PBS shows about space. And so I just really loved the kind of idea of it. And then I learned that you could be an astronaut and then go to space. And I was like, great, that's what I'm going to do. And now I build stuff that goes to space. So that's like pretty close to what I originally wanted. But so there wasn't like one question that kind of started it. It was more of just like, I thought that space was really cool. And I wanted to, be someone who like discovered things in space. And I feel like a lot of the questions that I want to answer, like how does a galaxy form, maybe will be answered in like a couple hundred years. But I hope that my like work will add like a teeny bit of our understanding of these like really complicated fundamental structures.
Awesome. Great. I'm not going to answer that question, but because I don't work in astronomy, I just tell stories about astronomers. So
you love space. I think you love space.
I absolutely love space. Probably for the same reason all the viewers do, why they're so fascinated by this. It's the last frontier, right?
Yeah.
That's why we call it, that's why we name the show New Frontiers. So
I think it's like a fundamental human thing. I think that all humans love space. I like have not yet met a person, no matter how grouchy they are, that when I hear that I'm an astronomer, they don't have like something fun to say about space.
Absolutely. And, I mean, part of me wishes I could go back in time before we had all this light pollution and I could see the sky every night looking up at it. And I'm sure all of our ancient ancestors, had an intimate relationship. If that's up in the sky every night, just the Milky Way and all those stars, I imagine that it like Erika said, it's just a part of just something deep inside of human curiosity and human nature. So another question about some of the OSIRIS-REx samples. Again, I want to remind everybody that we are not actually on the research team for OSIRIS-REx, so we may not have the answers, but Erika, do you have any idea how the clays might have formed that might contain some of that water within the samples of the OSIRIS-REx samples? And can you name organics or amino acids?
So I actually am not sure exactly how the clays would have formed. Our idea of the formation of the solar system is a lot of like kind of guesswork based on what we see, what like the end result that we see now, and evidence of things like, the moon having formed and material from meteorites that have landed on the Earth. So one of the big questions is like, what's the amount of water that was present in the forming solar system and where was it located? So if it's located, the models suggest that it's located farther out than the orbit of the Earth. And so then like, how did water get to Earth? So one of the big questions that we're trying to answer, that the OSIRIS-REx will hopefully answer, is the amount of water that was on Bennu. And I'm not a potter either. So I feel like clay, you need certain types of material and you need water to like make it form. And so the big thing that's I think more important is like the presence of water when these objects were forming, and what that might say about the prevalence of water just like overall in the solar system.
Great. Hopefully that gives you guys a little bit of the answers you were hoping for.
We'll have to check back in.
Absolutely.
Back in here.
Yeah. Future episodes of New Frontiers as well. We'll be covering these stories. So we do need to wrap it up. We're running out of time here, but Erika, if you want to just remind people what your handle on Instagram is so that they can find you. We had somebody ask about that. And of course that solar eclipse is coming up. You said that you've got a lot of stuff upcoming about that. Can you tell us a little bit more about when that's coming and what everybody here in Tucson should expect from that before we go?
Yeah, so my Instagram is just my name, Erika.Hamden, Erika with a K. And the eclipse is there's a total solar eclipse coming to North America on April 8th, and I've seen 2 total solar eclipses in my life. I'm driving to San Antonio to see the next one, this one in April. And they are by far the coolest thing that I've ever experienced. Like, it is otherworldly and just like so awesome. So if you can drop what you're doing and drive to the path of totality, the closest thing to Tucson is it goes through Texas. You should do that. Like, get there the night before. I'm going a couple days early, and it is like worth all of the hassle because it is just like the coolest ever. If you can't go and you're in Tucson, you'll still get to see a partial solar eclipse, which is also awesome. You should get eclipse glasses. You could order them online. There's like an ISO standard to make sure that it's protecting your eyes, because looking at the sun is very bad for your eyes unless you have the right protection. And it'll be a similar experience to the partial solar eclipse that happened also in Tucson in the fall. It'll be really cool. You can see like the shadows are different. It takes place over like several hours. It's a pretty slow thing. And you may be able to get eclipse glasses at like the Flandreau Planetarium, or the Phoenix Science Center has eclipse glasses for sale. You can also make like you can make like a pinhole camera to see how the sun looks without looking directly at it. But it's a really fantastic experience. And if you can go to the path of totality, like, you should definitely do it. Eclipses are the best.
I wish I could do that myself. I'm going to be on Mount Lemmon, actually at the Sky Center, doing a story up there. So stay tuned. It's going to be about the Sky School up there, and we're going to see a bunch of high school kids checking out the eclipse while we're up there on Mount Lemmon. So yeah. All right, with that, thank you everybody for stopping in, and stay tuned for more episodes of New Frontiers coming down the line. And yeah, it was great to present it for you all tonight.
Yeah, thank you for coming. Thank you, Bryan.